Picture this. You're standing in Yellowstone National Park. It's absolutely breathtaking, right? Geysers shooting spectacular plumes of water into the sky, these vibrant, almost unearthly hot springs, and endless quiet forests. But beneath this tranquil, picture-perfect surface, well, there lies one of the most unimaginably powerful forces on our entire planet. We aren't just looking at a beautiful park here. We are standing directly on top of one of Earth's largest volcanic systems. It's a literal geologic titan that has violently reshaped our world in the deep past. And honestly, its sheer scale, it kind of challenges human comprehension.
So it brings up the ultimate question, doesn't it? What if Yellowstone erupted tomorrow? It's a scenario that definitely captures our darkest imaginations. If this massive system were to just wake up tomorrow, in our modern, hyper-connected world, how exactly would that unfold? What would happen to our skies, our food supply, basically our entire global society? Okay, let's dive right into this. In this explainer, we're going to strip away all that Hollywood sensationalism and confront the strict scientific realities of the beast beneath the park.
All right, let's start with Section 1, the monster beneath Yellowstone.
To really grasp the stakes here, we have to totally throw out our normal ideas of what a volcano looks like. You definitely won't find a classic cone-shaped mountain in Yellowstone. Scientists actually classify it as a supervolcano. And no, that's not just some dramatic media buzzword. It is a strict scientific classification for a volcanic center that's capable of ejecting more than 1,000 cubic kilometers of material, we're talking rock, ash, and pumice, in a single catastrophic event. It is quite literally the highest classification of volcanic power we know of. Now, I want you to really hold on to that number for a second. 1,000 cubic kilometers, because it is incredibly difficult for the human brain to even visualize that sheer volume of material. I mean, imagine a solid cube of rock that is 1 kilometer wide, 1 kilometer long, and 1 kilometer high. Massive, right? Now, multiply that gigantic block by 1,000. That right there is the bare minimum threshold of material ejected to even qualify for the title of a supervolcano.
When a supervolcano erupts, it violently empties out so much magma that the earth above it just collapses in on itself, forming a massive crater known as a caldera. And this brilliantly illustrates just how colossal this structure truly is. Yellowstone's caldera measures an astonishing 70 by 45 kilometers across. To put that into perspective for you, you could fit entire major metropolitan cities inside that footprint with room to spare.
Moving on to Section 2, History of Massive Eruptions.
You see, this isn't just some theoretical threat. The geologic record absolutely proves that this supervolcano has fundamentally reshaped the continent before. The rocks beneath our feet tell the story of 3 massive caldera-forming eruptions. The first cataclysm, that occurred roughly 2.08 million years ago. The giant awoke again 1.3 million years ago, and then most recently, about 631,000 years ago. So we are looking at a repeating cycle of unimaginable power.
But it is absolutely vital to understand that since that last massive eruption 63,000 years ago, the volcano hasn't just been, completely dead. Activity hasn't stopped. The system is continuously breathed, producing smaller lava flows and all those incredible hydrothermal events like the geysers and hot springs that we see today. The magma chamber is still very much there, still hot, and still actively interacting with the world right above it.
Which brings us to Section 3, the global fallout.
Now, if that deep time cycle actually culminated in a modern-day super-eruption, well, the immediate vicinity would be completely decimated by pyroclastic flows. Those are superheated, incredibly fast-moving avalanches of gas and rock. But the primary weapon? That's the ash. Widespread ashfall would basically instantly blind global aviation. And under the crushing weight and toxicity of all that ash, we would see massive agricultural failure, which would rapidly sever our highly fragile global supply chains.
And the devastation wouldn't just be limited to the ground level either. The eruption would inject millions of tons of volcanic sulfur aerosols incredibly high into the stratosphere. So the crucial point is, acting basically like a giant planetary mirror, these aerosols would reflect the sun's radiation right back into space. This would violently alter global weather patterns, effectively plunging the planet into a deep, dark volcanic winter for several years.
So yeah, the stakes are undeniably high. A super-eruption would present absolutely unprecedented economic and agricultural strain to modern society. It would be a nightmare. But here's where the scientific consensus offers some reassurance. The geologic and historical records do not indicate that an eruption like this would cause human extinction. I mean, our early ancestors survived the fallout of past supervolcanoes, and humanity would survive this one too, though for sure it would be in a deeply, deeply altered world.
Let's pivot here to Section 4, Watching the Sleeping Giant.
So how exactly do we live safely on top of a sleeping giant? Well, let's move to Yellowstone and see how this builds. Because there is a massive disconnect between the public fear of a sudden, out-of-nowhere eruption and the actual scientific reality. According to current geologic evidence, a catastrophic eruption in the near future is extremely unlikely. The system simply isn't showing the signs of a waking giant. We're safe.
And scientists know this for a fact because Yellowstone is literally one of the most heavily monitored patches of Earth in the entire world. They use an absolute arsenal of continuous monitoring tools. I'm talking pinpoint earthquake tracking to map out any magma movement underground. They use GPS to monitor if the ground is swelling even a tiny bit. They constantly analyze gas emissions, use advanced satellite observations, log geothermal temperatures, and track even millimeter-scale ground deformation. It's just a massive, high-tech net that misses absolutely nothing.
Because of this rigorous 24/7 monitoring array, we can definitively say that a supereruption would not catch us by surprise. There is just no way. Magma moving in volumes large enough to trigger a massive event would cause the Earth to heave, fracture, and vent in some very, very obvious ways. Scientists would expect substantial warning signs. We're talking likely years, if not decades in advance, long before any major eruption actually occurred.
And finally, Section 5, Earth's Dynamic Interior.
Now, what's really interesting about this is how it shifts our perspective entirely. Yellowstone isn't some ticking time bomb meant to terrify us. It is a literal window into the engine of our world. Human ingenuity and scientific monitoring remain our absolutely greatest tools for understanding it. We don't have to live in blind fear of the unknown when we have the tools to measure, map, and truly understand the deep Earth. Knowledge, as always, is our best defense. Ultimately, Yellowstone is a remarkable natural system that perfectly highlights Earth's dynamic, ever-changing interior. It is a powerful reminder that the ground beneath our feet is alive with heat and immense power. So, the next time you see a geyser erupt, take a moment and ask yourself, are we just temporary guests on the surface of a world whose true power is patiently waiting below?